In this lesson, we'll talk about making copies of objects in Java, specifically shallow and deep copies. Right? So let's start by considering a piece of code. So in this piece of code, there is a hypothetical circle class, and I have two variables, circle1 and circle2. Circle1 is created using the new operator and calling a constructor. Circle2 is then equated to circle1. Now, the thing to realize here is that both circle1 and circle2 are pointing to the same circle object, right? Only the object reference has been copied by doing equal, not its content. So you haven't created two objects here. There's still only one object. Now, to make a true copy of the contents, you need to implement something called the cloneable interface. So let's talk about that in more detail. So to make a copy of an object, we will use a method called clone, right? And an interface called cloneable, right? The cloneable interface lives in Java lang package, and it's actually an empty interface, right? An empty interface is also referred to as a marker interface. It's used to denote that the class has certain properties. A class that implements clonable is marked clonable, and its objects of that type can be copied using the clone method. The clone method comes from the object class, which is like the top level class of all objects, right? It's the superclass of everything. Now, recall that there are other methods that we have used previously in other lessons that we get from object, and specifically toString, to generate a string representation of the object for printing purposes, and equals that not only compares it actually compares the contents of the object, right? So there are many classes. There are classes that implement the clonable interface, such as date, calendar, and so on, right? So let's actually try to use it before we define our own clone methods. So for that, let's actually use the date class, right? I said it already implements clonable. So let's see what it does. So here I have a main class with a main method, right? So it's runnable. In the main method, I have three variables of type date. The first one I am creating using a constructor. The second one I am equating to the first one. And in the third one, I'm actually using the clone method to make a copy of it, right? And I have to do this casting here because the clone method is provided by object. So this will return something of type object, and I have to kind of cast it to make it date. And then I print is D1 and D2, are they equal? Are they pointing to the same thing? And is D1 and D3 equal? And then I use the equals method to check whether they're truly equal. So let's actually run this, and we'll talk more about why the results are such. So let's open up IntelliJ, and I have the code here. It's already typed up, and let's first run it. What we should expect is the first returns true, then false, and true. So we run it, that's what we get. Now let's actually look at the code and see why that is, right? So the equal to operator gives us true if the variables point to the same object, right? So here D1 and D2 indeed point to the same object. They're not two objects, two different objects. They're essentially the same object. Okay, now let's look at D1 and D3. Now D3 was created with a clone, so there's actually a different object that was created. So this would be false. They're two different objects, and the variables point to them. Then the last one uses the equals method that's provided by object, and it goes and compares the contents of the two. And it only returns true if they may be separate objects, but if the contents are indeed the same, right? And in this case, it's cloned, so that must be true, and that's why you get true. All right, let's return to the lesson. Now, we've used cloneable, so let's talk about what it means to implement cloneable. Now, a class that implements cloneable needs to override the clone method that comes from the object class, which is the superclass of everything. So let's update our hypothetical circle object from previous lessons to implement cloneable. To do that, we obviously have to say implements cloneable, and then we need to create a clone method. And the clone method is declared as such. So it'd be important to look at the clone method as is defined in the object class. In the object class, it is defined like this. There's protected native object, which makes sense because this is within the object class clone, and then it throws clone not supported for things that you have the option to say, no, I don't really support clone that way. So let's take a look at each one of these modifiers. Now, the keyword native means that it is implemented within the JVM itself. It is not coming to you from a package, right? The keyword protected restricts it to be used only by subclasses, right? So now, what this means is somebody as some other class cannot use the clone method for circle unless circle actually goes ahead and implements it and makes it public, right? The circle, it must be overridden as public to be usable by other packages, right? So that is why you have to do it. You don't, I mean, there'll be no compilation error if you don't do it. But it is something that won't be available publicly to other classes to use. So you obviously have to implement it and make it public. Now let's take a deeper look at our new clone method. You'll notice that it is calling super.clone. So what's happening there? The clone method in object is being invoked using super.clone. So here, the clone method that is called is the one that belongs to object, right? So what does that clone method do, right? So the clone method in object copies each field, right, from the original object to the target object. So let's take a deeper look at what that means. So what that means is, if a field or a member variable is a primitive, right, such as radius or some value in int or something like that, the value will be copied, right? Now, if the member field is an object such as date created or something, or string, a reference is copied, right? So, you haven't quite gone and made a whole copy of the object. You made copies of the primitive values, but you have copied references to member variables that are themselves objects, right? So this is known as a shallow copy, right? Only object references are being copied, not their contents, right? So if you want to make a proper copy, it's a deep copy, you need to copy the contents of those objects as well, right? So to perform a deep copy, the new clone might look something like this, right? So the same method with the same signature. First, we make a shallow copy, and then we use clone to make copies of each of the member variables that are themselves objects, right? So we have the shallow copy using superclone, and then we make a deep copy by calling clone on each member variable that is not a primitive, that is itself an object. Okay. Now, the final thing we want to talk about in this lesson is the notion of a copy constructor. So let's talk about that. Right. When you're defining a class, you have various kind of constructors, right? The default constructor with no arguments. You can also create a constructor that takes an object of the same type and creates a copy, right? So a copy of an object can also be obtained, besides using clone, can also be obtained using a copy constructor. Such a constructor takes another object of the same type as a parameter, right? So in the case of circle, this would look something like this. You would have your other constructors, but you'd create another constructor which takes another circle object and does a shallow copy and a deep copy, and obviously the constructor will return the object itself, right? So that's another way to make a copy of an object. So let's see, how would you call something like this? So our use would be, we could take a look at this example for its use. We have 3 different circle variables. The first one we call the default constructor. There's another constructor with the radius. And then finally we're calling a copy constructor. We're passing in a copy of C2. Now this line here is exactly the same as doing this line, right? Where you're actually calling clone, which is the new clone is making a deep copy and returning it, right? Notice you have to cast this to circle because the clone signature returns something of type object. All right, so this has been a lesson on making copies of Java objects. Thanks.